Okay, this is a continuation of Section 6.6, Unit 11, Algebra 2, Semester 2. That battery ran out right on the end of this problem, and I want you guys to be able to see it, and then I'm going to go ahead and work the rest of these with you real quickly. So, on this one, you squared each side to get rid of that radical over the 7x plus 15. When you squared each side, it canceled the radical. That caused you to have x plus 1 squared. You know from all the polynomial work that we've done, x plus 1 squared is x plus 1 times x plus 1, which ends up being x squared plus 2x plus 1. You should probably have that memorized by now because it's the perfect square. And then we have 7x plus 15. Now, since we have a quadratic, meaning that x squared term in here, we want to gather all the terms over on the left-hand side and set it equal to 0 because we want to use our product property of zeros to get our answer here. So we draw our line down, we subtract 7x from each side. So that will make x squared minus 5x, positive 2x and a negative 7x is a negative 5x, plus 1 equals, those cancel and we get 15. Now we have x squared minus 5x plus 1. We need to get that 15 out of there to get it set to 0. Anytime you have quadratics, try to set them to 0 so that you can see if you can factor. That will cancel and we get x squared minus 5x. A negative 15 and a positive 1 would be negative 14. Equals 0. So now we look at this and we think, do we have any factors that multiply to be negative 14 and add to be negative 5? You can do the shortcut and put your factors straight into your binomials, which would be negative 7 and positive 2, which tells us that we have x equals 7 or x equals negative 2. Because when x is 7, 7 minus 7 is 0, and then that 0 times whatever this is would equal 0, or negative 2 plus 2 is 0, and that 0 would make the whole thing equal to 0. So now we should check those two and make sure that they work. So we plug negative 2 back in up here. Negative 2 plus 1 would be a negative 1. Square root 7 times negative 2 plus 15. So negative 1 equals the square root of 14, negative 14, plus 15. Negative 14 plus 15 would be 1. The square root of 1 is negative 1. That doesn't really work. Okay. It is one of the options. Negative 1 times negative 1 is 1, but not our favored. So let's look at the other one. 7 plus 1 is 8, or I'm sorry, 7. That was our other option there. 7 plus 7 is 14, and we have 7 times 7 plus 15. 7 times 7 is 49. Plus 15 is 64. And I'm sorry, that's not a 7 plus 7. Our original problem is 7 plus 1. So 7 plus 1 is 8. And 8 does equal the square root of 64. So this answer is good. We need to talk about this negative 2 in class. So come in tomorrow with all of this problem here, and let's talk about this solution compared with that solution. Make sure and ask questions. Why would this one not be so good? And this one is good. And maybe you have some answers already. So come into class with those. Okay, here we go on this problem. We need to get rid of that 3/4. Now, one option here is to not go into the radical. We could raise the whole thing to 4/3. Let's see if that works. Let's just play around with this and see if that works. First thing we want to do is get this one over here, because we'd like to deal with the exponent by itself, and we want to get the x alone eventually. So we add 1 to each side. We get x plus 2 raised to the 3/4 equals 8. Now, we had somebody in class ask, can I just raise this to the 4/3? So I want to show what happens with that. I love it when you guys think of other ways to do things in math. We'll see if it works. 4/3, and we'd raise this to the 4/3. So 4/3 times 3/4, those will cancel out because it's 12 over 12, so it's equal to 1. So now we have x plus 2 equals 8. Now that's going to be the cube root of 8 raised to the 4th. Okay? Let's go ahead and simplify that. Cube root of 8 is 2. Raised to the 4th would be 16. We have x plus 2 over here. X plus 2. Subtract 2 from each side, and we get x equals 14. So now let's see if it works as a solution. That's part of seeing if our new method worked. So we take 14 plus 2 is, well, let's go ahead and plug it in there. 14 plus 2. 14 plus 2 is 16. Now this is saying the 4th root of 16 raised to the 3rd minus 1 equals 7. 4th root of 16 would be 2. 2 raised to the 3rd would be 2 times 2 times 2, which is 2 times 2 is 4, times 2 is 8, minus 1 would be 7. So it does check. So we can go ahead and use that method. You can come into class. If you have other ones that you want to see, hey, can I use this kind of method on it, then feel free to come by and see me, and we'll get it on the tape and let others know about it. Okay, next one, we have square roots on each side. I hope you noticed that, and that could be a little bit of a problem. So the first thing that we want to do is we want to square that, just to get rid of, at least rid of this side. It will do, it won't completely get rid of it, but we'll see what happens over here. So first thing is, we're going to square each side. And now we end up, this one completely cancels here. This one, we have to treat actually like a binomial, since it truly is, x plus 2 plus 1 times square root of x plus 2 plus 1 equals, now we can write that other side without the square root, so it's 3 minus x. Okay? Now the square root of x plus 2 times the square root of x plus 2 would come out being x plus 2 without a square root. The middle term would be 1 radical x plus 2, and then the outside term is 1 radical x plus 2. So that makes 2 of those, 2 radical x plus 2's. And then the last term is 1 times 1 is 1, equals 3 minus x. Okay, So now I know that we have this square root, but we're still going to try to gather the x's over here on the left-hand side and set it equal to 0 and see where we can go from there. So to get rid of the x's over here, we add x to each side. We end up with 2x plus 2 plus 2 radical x plus 2 plus 1 equals 3. Let's again try to take care of this in the most systematic way. I think I should go ahead and gather my like terms together where I can. So let's rewrite this. 2x plus 2 radical x plus 2, and then if we have 2 plus a 1, that would be 3 equals 3. Now if we subtract 3 from each side, we can eliminate those two. So now we have 2x plus 2 radical x plus 2 equals 0. Let's see what else is common there. I do see where we could have a common thing of, well, we've got the square root and the x. Let's get them on separate sides again and see if we can do something that way. So ignore this assignment here. Let's move it over here. 2x equals, actually it's easier probably to move the 2x across. So let's subtract right here a negative 2x there, negative 2x there. We'll rewrite it with 2 radical x plus 2 equals negative 2x. Now we can divide by 2 on each side. I see that. And we would end up with radical x plus 2 equals negative x. Now let's square each side to get rid of the radical. And that would get rid of that radical. We'd have x plus 2 equals negative x times negative x would be a positive x squared. Oh, now we've got a quadratic. So let's gather it all together. Let's bring this x over and this 2 over. And we would have 0 equals x squared minus x minus 2. It's a nice quadratic to factor, because we know in order to get negative 2 as a product, we need to have a negative and a positive, and 2 and 1 would be our only factors that work. So we know that x is going to either equal, because it has to be the opposite of what's in here, you're setting that to 0. So when x is equal to 2, that will be 0. And when x is equal to negative 1, that will be 0. Go ahead and check that. Highlight your questions. We can run through that one again in class. There may be some people that are wanting to try something different or want to ask if something different would work on that one. So highlight it when you come to class. You will be working on this page 456. And that finishes this unit, so you'll start getting ready for the test. Make sure to ask for a study guide. Thank you very much. We'll see you in class.